Stoufflet, and I teach 9th grade Algebra 1 at Terrebonne High School in Terrebonne Parish. As an educator, I am most passionate about creating an environment in which students feel safe and respected by not only myself, but also by their peers. It is a priority of mine to make sure that all students are heard and they know I value each and every one of them. The lesson that I taught today dealt with getting students to start to understand and visualize the difference between linear and exponential functions. By the end of the lesson, students should be able to describe, using words and expressions, patterns and tables that represent linear and exponential relationships. In accordance with my district, I used the illustrative mathematics curriculum to teach today's lesson. Prior to this lesson, students have been taught about linear functions for months. However, the idea of exponential growth was only briefly hinted at in yesterday's lesson. Today is the first day students truly start to see and visualize how exponential relationships will grow in comparison to linear relationships. Things you need to know about the learners in my classroom is that while they are all honor students, they all have significant gaps in their math skills. This is due to them missing a month of school last year to Hurricane Ida, and because of this, students did not perform as high on their 8th grade LEAP as honor students typically do. In order to support all learners, students have been grouped with a shoulder partner that is at their level. This allows me to know which groups typically struggle and need more support, and which groups need higher level questions.
Once you're finished your bell ringer, you're opening up the correct lesson. Okay, so it's lesson 2. Lesson 2. Okay, a little less than 1 minute remaining for those still working on their bell ringer. A little less than 1 minute remaining. Volunteers to come up here and do the bell ringer. Volunteers. Okay, Zoe. Alrighty, as Zoe is up here, just make sure, as always, that you are only talking if Zoe calls on you. Floor is yours.
Okay, the graph of this function is a straight line. So is it linear, exponential, or neither? Kinsey?
It's linear because linear is a straight line.
Perfect. The graph of this function is a curve going up really fast or going down really fast. Okay. Good, because it's curved.
What was that? I didn't quite hear you.
Because it's curved. It's a curved line. Is this equation linear or exponential? I can
Compare linear and exponential functions. Alrighty, so as y'all are exiting out of your bell ringer and getting on to today's lesson, you will see, based on our I can statement, we are continuing what we have been talking about the last 2 days. Okay, so looking at a linear function, what exactly makes it linear, and then what exactly makes it exponential. So we're still on that same target rule here. And so what we're going to do is we're going to start off with a which one does not belong. Now remember, when we have these which one does not belongs in our book, there's always a reason that one of these tables does not fit in with the other 3. So what I'm going to have you do in a second is I'm going to allow you to talk to your partner. We're not going to move quite yet. We'll save that for the end of the class, but we'll just turn and talk to our partner about why each of these tables is different than the other 3. Okay, I do not need you to type. Okay, I do not need you to type anything. I just need you to discuss with your partner. I'm going to give you about 20 to 25 seconds for each table. Is everybody clear on that? Okay, so the table we're going to look at first is table A. So right now, go ahead and turn to your partner, please. And you may begin discussing.
I'm thinking table A.
Did any of our other 3 tables do that? No. Okay, so that is one reason. Did any group come up with another reason? Okay, Callie, what did you and Rylan talk about?
Table A's x starts with 1 while the other ones all start with 0.
Alrighty, it is the only one that starts with 1. The other 3 are all going to start with x being 0. Yes, ma'am?
We said that it's a linear equation because it adds by 8 on the y side.
Alrighty, that is very valid, and that is something I want us to get in the mindset of seeing. So she said it is a linear equation because if we look at this, as our x values are adding by 1, our y values are adding by what? 8. Now, there has been some confusion in earlier classes today about when we get to these last two right here. Okay, tell me, why is table B different than our other 3 tables? Yes, ma'am, Trinity.
It's increasing by 16.
Okay, so Trinity says it looks like this table, our y values are increasing by 16. Do we agree with that statement? Okay, would you like to add to her answer?
I was also going to say that this one is definitely exponential.
Okay, so she is saying that this one is definitely exponential, and what leads you to believe that this one is exponential?
Because you can technically multiply the y-axis by 2 and it keeps getting higher and higher.
Okay, so she said we can multiply the y-axis by 2 and it keeps getting higher and higher. Do we all agree with that?
No.
No. Okay, so let's think about what's actually happening here. Would you like to help her out?
In the x column,
Linear.
it's also
Okay, table C. Once again, 25 seconds. Y'all may begin discussing.
Every time it's increasing by 1.
Give you a hint. Make sure it does not matter if it's positive, negative, anything like that, but show me with your arms a linear function. Linear. So no matter how your arms are right now, if you kind of look around the room, what do y'all all have in common? Someone raise your hand and tell me, what do y'all all have in common? Mackenzie?
All the lines are straight.
All of your arms, okay, all the arms are straight, so are they all lines?
Yes.
Will a linear equation always form a line?
Yes.
Always. Now, when we think about an exponential function, this is the one that's new to us, okay? We've only been talking about this a handful of days. Can anyone show me what an exponential would maybe look like? Okay. All right, I see what we're trying to do. Main thing, will an exponential be a line?
No.
No. So as we may or may not recall from the last couple of days, when we have an exponential function, do y'all agree it's going to start off, it's increasing, but is it very gradual?
Yes.
Okay, but will it reach a point where it kind of just starts to skyrocket? Okay, so it's kind of going to have that curve shape as Zoe and a few of y'all were discussing during the bell ringer. Okay, so it's going to start off gradual and then it will curve. What we're going to do is I'm going to set a timer for about a minute and a half, and I want you and your partner to discuss why they are alike and why they are different. Okay, so why they are alike and why they are different. Is everybody clear on that? Yes. Are we sure? Okay, and in order to do this, I want you to go ahead and slide with your shoulder partners. So rows B, D, and F, slide please. Alrighty, begin discussing.
Factors from plan B and the difference from variant A states and starting at
Yes, ma'am. Alrighty, so she said for a number of stores for plan A, we're adding 20, whereas for plan B, we are multiplying by 2. Do y'all agree with that statement?
Yes.
So furthermore, if we add to her answer, what is that going to mean? What does that mean? Mackenzie?
Plan A is a linear function, and plan B is an exponential function.
Alright, she says plan A is a linear function, plan B is an exponential function. Give me a thumbs up if you agree with that. Okay, I agree, and so that's the big thing here. So notice, when we're adding, we are going to have a common what? Difference. Okay, so linear functions will always have a common difference. Exponential functions, what are they going to have in common?
A common factor.
A common factor. So if I say I have a common difference, what kind of function do y'all know I'm talking about?
A linear.
Linear. If I say I have a common factor, you should know what I'm talking about.
Exponential.
Exponential. If I say I have a constant slope, Think about that. If we have a constant slope, what is that?
Linear.
Linear. What about a constant rate of change?
Linear.
Linear. So constant rate of change, constant slope, common difference. Is that all essentially talking about the exact same thing today? Is on your screen you should see a set of 8 cards. Okay, you should see a set of 8 cards, and on these 8 cards we are going to separate them into 2 piles. Each of these piles is going to have a situation, a table, and 2 expressions. So how many piles of cards will we have? 2. Okay, and so this will be our closure, or our exit ticket today. So I want you and your partner to go ahead and sort these.
In looking at the data from this lesson, I was able to see that overall students did meet the objectives of this lesson. I was able to see based upon the matching activity that I had students complete as their exit ticket. Students were able to successfully match the situations to the table and expressions, showing their ability to distinguish between linear and exponential functions. If I were to do anything differently with today's lesson, I would allow students to work with their shoulder partners for the second table in the lesson. I feel as though this would have been another quick formative assessment for me to monitor and review the students before we got to their exit ticket. Overall, I am very pleased with how today's lesson went.